Okay, we're going to take a look now at question 5 from AS2 Physics 2 January 07. Now this question is essentially a diffraction grating question, which, as I mentioned previously, is no longer on the specification. However, it does have little bits of diffraction which are important to us, so I'm just going to pick those out. The first of those is part 1, which is just describe what is meant by the diffraction of waves. This is a very, very common question, and remember, diffraction is the spreading of waves. So diffraction is the spreading of waves, but we need a little bit more than that. Spread of waves through a gap or aperture or around an obstacle. Now in the mark scheme it just happens to mention that's into areas of geometric shadow. Now that just means that it goes into areas where you wouldn't expect it. If it just went straight through without spreading, it would leave a geometric shadow. So if it was a circle, it would show the shape of the circle. But here what you find is it spreads into areas beyond that circle. As I say, the next part of the question are all diffraction grating, explaining diffraction grating, and then do a calculation, and then it goes on to talk about electron diffraction, which again is part of our current specification. So the first part here asks us to state the item used in the electron beam experiment which fulfills the role of the diffraction grating. So here, rather than using a diffraction grating, what we have is a metal foil, or in the original experiment it was a graphite film. Right, so a metal foil or a graphite film, and that's because the spacing between the atoms within the graphite film, or between the metal foil excuse me, are about the same size gap between those as the wavelength of electrons which are accelerated at that. Illustrate with a sketch the type of pattern obtained in the electron diffraction experiment. Well, we get a series of bright and dark fringes. This time though, there are a series of concentric bright and dark fringes. Okay, so we get this pattern which looks a little like this. Okay. The only thing to be very careful with here is that you need to label that as a central bright spot, okay, which is what's produced, and then these are bright fringes, just to ensure. So it's a bright fringe in the center and then surrounded by bright dark coming out from there. Alright, there's a major necessary difference in the experiment which must be to successfully conduct an electron diffraction. Well, the difference is electron diffraction has to be conducted in a vacuum. It will only occur in a vacuum. So it must be carried out under vacuum conditions. Carried out in a vacuum. So in order for us to observe electron diffraction, we require a vacuum tube. And you should remember, although we're not being asked for it here, but you should remember that what we've got is, in our diffraction experiment we had a vacuum tube, so we have a vacuum here. On this side here then, around down here, we would have had a fluorescent screen. We then have our anode here, and we have our cathode here, which is going to be heated. So we have our cathode and anode. We apply a high potential difference between these. Electrons are produced. The electrons then accelerate through here, and then they hit the graphite target here. Okay, so that would be our graphite target. And on this screen here we produce a typical diffraction pattern, which is a series of bright and dark concentric circles.